Hayalperestlerin, risk alanların, denemekten korkmayanların cesaretinden doğduk. Bizi asla yarı yolda bırakmayan o sesin rehberliğiyle ilerlemeye ve öğrenmeye devam ediyoruz. Bunun için varız. Bu yüzden gece geç saatlere kadar lambalarımız sönmez. Elveda demek hem hüzün hem de gurur verir. Her şeyi sorgulayarak ve merakımızı besleyerek, dayanıklılığımızı test ederek, sınırlarımızı aşarak, ilerleyerek ve yeni ufuklar açarak yeni bir yol buluruz. Yeni icatlar çıkararak, kendi yolumuzu çizerek. Burası fikirlerin doğduğu ve yeni fikirleri doğurduğu, bizim de doğduğumuz, birlikte büyüdüğümüz ve yükseldiğimiz yer. Burası Yakın Doğu Üniversitesi.
Welcome everyone. Welcome to our last session of our conference for the first day for Room 1. Would like to start by our first presenter, Mr. Declan Emigano, who will present the paper titled Predictive Modeling of Groundwater Contaminant Transport. Hello, Mr. Declan, and welcome. Please share your screen with us.
Okay.
Just click present, then share screen, then window, and select the PowerPoint window.
Can you see my screen?
Yes, we can.
Okay.
Thank you.
You're welcome. I'm talking about, good evening, everyone. I'm talking about predictive modeling of groundwater contaminant transport, integrating environmental factors and the hydrochemical parameters. So my name is Declan Emigano. On behalf of our research center, I'm here to represent, as you can see from the slide, the members of the research center that contributed to this paper. So these are my outlines. We'll talk about the introduction, what groundwater resources are and the contaminants, and especially in the Eastern Hemisphere, the types of contaminants, modes of the contaminant transfer. We talk about the data and we'll discuss, we simulate the data, we talk about the results and compare the models, and we conclude the study. So when we're talking about contaminants, we meant impurities that impair water use. So these impurities, they adversely affect the entire ecosystem. As a result, we say groundwater contaminant transportation is a complex situation. It's a very tremendous problem that affects human health and environmental sustainability. It's also become a threat to the well-being of the entire populace. So globally, groundwater is used for many purposes. We can, water, you can drink it, we use for farming, we use for irrigation. So looking at the Eastern Hemisphere, like where Turkey is, Iran, and to the rest of them, France, you can see the work that has been done by this. So this, you can see the contaminants that have been detected, like volatile organic compound and emerging contaminants, especially they are here in Turkey. Turkey has almost 20,000 groundwater that has been worked on, and they were able to detect arsenic, nitrite, pesticide, and the volatile organic compounds. So when we look at that, we now say, okay, what are these contaminants? What are they? Or we have many types, several studies. They have categorized contaminants in diverse ways, but we just make them to be three. Basically, we have chemically based contaminants, which are highly carcinogenous. They can cause cancer. So these are contaminants from water side, from homes, and from industries. You can see from the pictorial representation how these contaminants affect the entire ecosystem. So we can talk about the radionuclide-based contaminants that comes from plasticizers, pesticide, medications, even from estrogen. So these they contribute to in the contamination of the water. Then we have the biological contaminants, whereby like human physics and animal physics, these ones cause serious problem. It causes harm. Like you can see this man drinking this water, and from the picture up, you can see that that is disposal of physics, and this one is washing, so it's causing adverse effects. The effect of this could be tremendous on the entire population. So these are the contaminants that we are talking about that affect. So now, how does this contaminant transfer? We have three major ways. We have what is called advection, and we have what is called adsorption. So the primary mechanism of groundwater contaminants is the advection, whereby it's solely dependent on the gradient differences beneath the surface and the geological comparison of the subsurface. So example are like in farmers, whereby the nitrates and the fertilizers all contaminate the farmland. Another one is adsorption, so whereby the contaminants are attached, that is, they are bonded either chemically to absorbent or the aquifer. So this is known as absorbent. So this interaction is what leads to absorption. So the next mode of transfer is what is called sorption, whereby solutes, like something gets contaminated or gets absorbed on the surface of the solid. So this absorption could be in advection, it could be dissolved materials, and these ones now that's how the water gets contaminated through sorption. Means it's the mode of this being transferred to farmland. So in this study, so when we look at it, we now said, okay, what are the models we are going to use in order hydrochemical properties and to make this study so academic. So we employ these 7 models. You can see from it. We use surface vector regression because it's a multi-purpose model and it's excellent in regression and classification of tasks. So we also apply the linear regression, which is based on the concept of variables, these variables that could be linearly related. So minus that, we also use the random forest. We also employed extreme gradient boosting, which is a powerful machine learning model for both classification and regression category. We also use a light gradient boosting machine. This one is quick and scalable machine method. So we didn't stop. We also apply support vector regression and boosted decision tree analysis. So these are the models we employed in this study to make it very wonderful. So as you can see, and we also applied multi-layer perception. So that is up these 7 models. So our data set, so we got this data from Earth data with this URL representation. So it's a water chemistry from Southwest Basin in the Brazilian Amazon. So the data is 3080 in number with 30 columns. So, and this data, it's talking about the watershed trees, whereby they are collected in different categories. So they have 1,758 data from water samples, which represent the pasture, and the other 1323 samples from water side. So when we got this data, we employed Microsoft Excel and Python in its analysis. So these are the variables, how it's being categorized. So when we now decide to work on concentration of nitrate, which is the most abundant contaminants on Earth, so we run the correlation analysis and now choose that nitrate as our target. So these are how these water sites are being distributed in this study. So we have the soil solution overload flow, and we statistically, you can see that TF, which is the true fall water, has the highest number of samples that are being used. So the data, we make the data from by normalizing it. This is the unnormalized data. You can see from the descriptive analysis. And when we normalize it, this is what we get. So this is our target variable, which is the nitrate that we are trying to use to predict this water contaminants on this data. So the correlation analysis made us to have that nitrates to use it as the target variable. So you can see the correlation, how correlated they are here, that the nitrites, the correlation value is 1, followed by manganese. These are other chemicals that are being correlated with nitrates in this water contaminant. So after this, we train the data sets. We split it into the training side and the testing side. So the training side has 2310 rows and 26 columns. After we must have removed some outliers from the ones we don't need from the data sets. And we now tested it with 771 rows and 26 columns of the data set. So after the simulation, using these models, these are our results. So you can see from this table our results, how it looks. So in these results, we find out that random forest regression, so it has a MAE value of the least one, 0.1947, and root mean square error of 0.467. So they are the most smallest, and that is the one that is, we can say that perform excellently in this modeling. So SGB is another model that is closer from the coloring. You can see there, and it has a root mean square value and MAE, both of them 0.4976 and 0.1992. So which is comparable to random forest regression. So when we compare these models, we find out that these 4 models, random forest, SGB, LDB, and the BTR, they had excellent outcome in doing these predictions. So you can see both from the root mean square value and the mean absolute error values, MAE, and they performed wonderfully well. Now, we also compared our study with already existed studies that have done before. So when we compared it, we find there was a study done by Ibrahim, but Ibrahim used 387 data sets, and in his study, he used generalized regression network, which we had similar values. Is getting his random forest 0.9 compared to our study, which is, so this is a bit far from this study. Another study we used to compare how robust our work was the work by Bedi et al. In September 2023. It was a recent work whereby he used 303 data sets, which is similar to us. And in comparison, his work was very nice because in comparison, his root mean square error was 0.47. Our own root mean square error was 0.46. So it's closer, and 0.39 for SGB, so 0.49. So this to show that our work is comparable, and MAE had 2.0, 2.01.8 respectively across all the models. So showing that our study is unique and it's really predicted the prospect for the future. So in conclusion, what we are saying is that groundwater contaminants, it has been a pressing issue globally, and the impact these does is very numerous because when we mitigate the effects, then it's going to be through our study. We are presenting to the opinion leaders that using study of 38 data sets and 30 columns, that we are saying that random forest regression had an outstanding performance in predicting this work with lowest root mean square value of 0.46 and the R value of 0.63 respectively. These are my reference. Thank you for your attention.
Yes, thank you very much. Thank you very much for your presentation. Any questions? Okay, since no questions, I would like to move on to the next presenter, Dr. Nrsem, that will be presenting the paper titled Temporal Assessment Vulnerability of Seawater Industrial in Chester, Blank Aquifer. Yes, please share your screen. Yes, present, share screen, then window, and select your PowerPoint.
Entire screen.
Present, then share screen. Then you can see window.
You have my screen?
Right now, no. Yes, wait.
No.
Yes. Yes.
Okay.
Thank you.
Good afternoon, esteemed colleagues and distinguished guests attending the third International International Conference of Water Problems in Mediterranean countries. In these slides, I will talk about introduction of my article, study area, methodology, and results and discussion. My paper title is Temporal Assessment of Vulnerability to Seawater Intrusion in Chester Plain Aquifer, a comparative study of 2003, 2013, and 2021. Our primary goal is to compare vulnerability levels across the three critical time points, 2003, 2013, and 2021. By utilizing a Galdit method, we've delved into the intricate dynamics of groundwater vulnerability, aiming to shed light on the changing landscapes of this vital aquifer. My study area is Chester Sofyan Plain, nestled within the Urmia Lake catchment area, and this approximately 1,300 square kilometers region is integral for agriculture and drinking water needs. The seasonal nature of rivers promotes heavily reliance on groundwater. However, challenges like reducing rainfall and increased groundwater exploitation have triggered a decline in water table levels and heightened seawater intrusion, posing significant threats to the aquifer vulnerability, to aquifer sustainability. Ensuring the robustness of our study required comprehensive data. We access groundwater level data, piezometric points, bedrock information, transmissivity data, and hydraulic conductivity from the regional water company of East Azerbaijan. These parameters, coupled with aquifer thickness data and point coordinates, form the backbone of our vulnerability assessment, and used geographic information system within the ArcMap. Galdit is an index-based that uses 6 crucial parameters, and groundwater, that G stands for groundwater occurrence, A stands for aquifer hydraulic conductivity, L stands for height of groundwater level about the mean sea level, D stands for distance from the shoreline, and I impact of existing states of seawater intrusion, and T stands for thickness of aquifer. As you can see in this table, that is a reference table, you can see parameters, weight, standard Gauss factor variable range, classes, importance rating, and as you can see, the L and D parameters affect more than others that the groundwater vulnerability assessment, and our aquifer is both confined and unconfined, which rates the highest vulnerability. Parameters G, A, D, and T, which can show, which is shown in the screen, are exhibited stability, reflecting unchanged geological condition. However, parameters L and I showcase significant changes, mirroring shift in precipitation patterns and groundwater extraction rates, which leads to lowering the groundwater table. The resulting changes, the resulting Gauss map illuminating vulnerability, indicating a notable increase from 2003 to 2021. Our conclusion will delve into the implication of these findings and their significance for the Shabistar aquifer. The Gauss map categorized into 4 classes of vulnerability: low, medium, high, and very high. As you can see, in years, the area in very high is increasing, and the area of aquifer itself decreased because of the increased amount of extraction, and the result shows that the aquifer is in a really vulnerable situation. In conclusion, the study focused on mapping the vulnerability of the Shabistar Plain aquifer using the Gauss method, which incorporates 6 crucial parameters influencing seawater intrusion. The results revealed that in 2001, the aquifer exhibited a significant increase in vulnerability compared to 2003. Only 9% of the aquifer was classified as having low vulnerability, while 64% had the medium vulnerability and 18 had the high vulnerability, and 9% had very high vulnerability. This suggests a decline in aquifer levels and overall increased vulnerability, particularly within the moderate range and higher, which saw an approximate 2% increase from 2000 to 2021. And these are some of my references that I used in my article. And thank you for your attention, presence. I welcome any questions or discussion you may have. Your insights are invaluable in future our understanding of and addressing the challenges post-seawater intrusion in the Shabistar Plain aquifer. Thank you.
Thank you very much, Yilmaz. Perfect presentation. Any questions? Okay, since no questions, I would like to end this session today. And this was our last presentation for today. Thank you, everyone, for your attention. Thank you, everyone, for your attendance. Appreciate it. Thank you very much again. See you tomorrow in our second day of our conference. Thank you very much.
Hayat hızla akıyor ve biz bu hızı seviyoruz. Her güne heyecanla başlıyor, her anı doya doya yaşıyoruz. İlk günkü heyecanımızla yılları aşıyoruz. Zaman akarken biz de kendimizi arıyoruz. Heyecanla, merakla. Sen de kendini mi arıyorsun? O zaman zamana yetiş. Bu sadece kendini bulmakla ilgili değil. Asıl heyecan kendini yaratmakta. Bir şeyler mi yaratmak istiyorsun? Mükemmel. Metali işlemeyi, bir bina yapmayı, bir iş kurmayı, hatta bir şehir kurmayı öğren. Hayat kurtarmak, teknoloji geliştirmek, üretmek. Hepsi burada. Ve burada tüm deneyimler profesyonellerle yan yana. Ancak hızlı ilerlemeliyiz. Çünkü bugün şimdi gerçekleşiyor ve yarın çok yakın. Hayatta öne geçmek istiyorsan önce zamanın önüne geçeceksin. Hep ileri gideceksin. Bu Doktor Suat İrfan Günsel. Tanıyor musun? Onun da söylediği gibi. Üniversiteler toplumların dokuma tezgahıdır. Toplumları geliştirir, dönüştürür ve gelişmesini sağlar. O burayı bugünden yarına hazırlamak için kurdu. Senin için, ileriye gitmek için. Yana ya da geriye değil. Sadece ileri. Çünkü gelecek çok yakın. Hadi harekete geç. Fikirlerin ne kadar ileride olursa yarına o kadar yaklaşırsın. Yanındakileri de geleceğe taşırsın. Bu senin geleceğin, senin fırsatın şimdi. Hadi yarını yakın.